Hey, you guys, ready for another lesson? All right, we're going to move on in Chapter 9 to Lesson 9.5, Congruence Transformations. So if you want to open your book up, it's going to be on page 578, Congruence Transformations. All right, so basically, you can use a composition of rigid motions to understand congruence. All right, so if we look at this problem here, identifying equal measures. We have a composition here, and I want to change this composition. So for this one right here, let's take this out and we're going to switch them. All right, so I want to do the rotation 90 degrees about point P. We're going to do that first, and then we're going to reflect it across line N. So we're basically just flipping them. So if you look at what it was underneath, I'm just flipping them. Okay, you can do it that way, but this is the way it is in the book. And I don't know how that got flipped, but it did. All right, so the composition of rotating 90 degrees about point P and then reflecting across line N, we're going to do it to LMNO, which is a quadrilateral, looks like a trapezoid, and we're going to end up with GHJK. So it says, which angle pairs have equal measures? All right, so first of all, if we're looking for equal measures, we can kind of tell, first of all, that the rotation of LMNO, it rotated here. And then the reflection was right here across. So that's the rotation and the reflection. All right, so all you have to do really now is just match up the angle pairs. All right, so which angle pairs have equal measures? So L and G. So angle L is congruent to angle G. M and H. Angle M is congruent to angle H. N and J. Angle N is congruent to angle J. And O and K. Angle O is congruent to angle K. All right, which angle pairs have equal measures? Check. All right, which sides have equal lengths? Okay, we can do this the same way. LM and GH. So LM, segment LM is congruent to segment GH. All right, MN and HJ. MN is congruent to HJ. All right, NO and JK. No, and just kidding, right? NO is congruent to JK. And then the last one, whichever way you want to write it, you can either call it LO or OL. I'm going to do LO is congruent to GK. So when you do a congruence transformation, you basically are taking the pre-image, you're doing some kind of transformation to it. In this situation, we rotated it 90 degrees about point P, and then we reflected it over N, and it was a congruence transformation. You started with LMNO, and you ended up with GHJK, and they're congruent to each other. You mapped one on top of the other. So it's really not any different than what we've been doing. We're just kind of combining them. So really, we didn't even have to see that picture. Right here, a composition of taking and translating triangle ABC 2 units to the right and 3 units up, and then reflecting it over line T resulted in triangle XYZ. So they're actually already in the order we need, and we don't have to write a picture of it. All right, this is the got it problem number 1 that you're going to be doing. List all the pairs of angles and sides with equal measures. All right, if you want to pause it and then come back and check, you can, but I'm going to go ahead and list the angles first. Angle A is congruent to angle X. Angle B is congruent to angle Y. Angle C is congruent to angle Z. All right, now we're going to do side lengths. So we're going to do segment AB is congruent to segment XY. Segment BC is congruent to segment YZ. And then segment AC is congruent to segment XZ. All right, list all the pairs of angles and sides with equal measures. All right, concept 2. This is on page 579. Identifying congruent figures. Based on the 2 previous problems, you saw that the compositions of rigid motions preserve side lengths, which is distance, and angle measures. There's another way to define congruence. If 2 figures are congruent, if and only if there is a sequence of one or more rigid motions that maps one figure onto the other, which is really what I've already said. That's what they did. But we're going to figure out what did they do to map one onto the other. All right, which pairs of figures in the grid are congruent? For each pair, what is a sequence of rigid motions that maps one figure onto the other? And it kind of depends on which one you're looking at as the original. So I'm going to start with, let's see, triangle. We'll start with triangle DEF. All right, so triangle DEF. Triangle DEF is going to end up being triangle. Now, this is 4 and this is 4. This is 4 and this is 4. Okay, so DEF is going to be LMN, triangle LMN. All right, now let's see how we can map one onto the other. What we could do is we could rotate it, right? We could take DEF and we could rotate it 180 degrees about the origin, right? And we would end up with triangle LMN. All right, so let's go ahead and write that transformation that we did. We are going to rotate 180 degrees about the origin. Okay, that works. That's a rotation, and that shows that the triangles are congruent. It shows which triangles are congruent. All right, let's go to ABCJ. Looks like a trapezoid to me. How about you guys? So we're going to put ABCJ. And we're going to map it onto WXYZ. WXYZ. All right, so let's see what we would have to do to trapezoid ABCJ to get it and map it onto WXYZ, because they're flipped. I can already see we're going to have a reflection going on. So let's see. We could reflect it over the y-axis. And by doing that, C would become here. B would be here. A would be, see, it's 4 away, so 4 away here. I'm going to put A prime, B prime, C prime, and J would be 2, 4, 6. So 2, 4, 6. That would be J. So we could do that. We could reflect it. All right, so let's write that. We're going to reflect it over the y-axis. And since it's a composition, we have to do something else. We're going to have to slide it up. So we're going to make it go up 1, 2, 3, 4, 5. And then it's going to go 1 to the left. All right, so it's going to be a translation. It's going to go 1 to the left, so that's a -1, and then 5. So you could actually go 1 left first if you wanted to, and then go up 5. And then it will map one onto the other. All right, let's look at the third one. It's just a segment, this PQ and this HJ. So let's say that it started at HJ. Let's say HG, sorry, not J, HJ. Let's say that's HG. Sorry, I keep saying HJ. Let's say that's the original, and we end up with a PQ. Think about what you're going to have to do to get it there. All right, I'm going to take the H, and let's go left first. I'm going to go left 2, so that means I'm translating it. I'm going minus 2. That's left 2. And then I'm going to go up 2, 4, 6, 8, 9. So I'm going to go up 9. So I translated it. Okay, which pairs of figures in the grid are congruent? And for each pair, what is a sequence of rigid motion that maps one figure onto the other? All right, let's go to the next page. This is the got it question. This is the got it question number 2. Which pairs are congruent, and what is the sequence of rigid motions? All right, so you can already tell which ones are congruent. Let's go ahead and start with the triangle. Let's start out with triangle UVW, and let's map it onto triangle. And you got to look at it and make sure you're mapping it the right way. UVW. We're going to do QNM because it looks like it's an isosceles triangle to me a little bit. We don't know for sure though. QNM. All right, so let's see what we're going to do. If we reflect it over the x-axis, our W would become here, W prime. Our U would be here, U prime. Our V would be 4 here, V prime. So this is what it would look if we reflected it over the x-axis. So let's do that first. Let's reflect it over the x-axis. And then let's translate it. Let's see, we're going to translate it. I think if I took U and I went 2, 4, 6 that way, I think it'll be good. W 2, 4, 6. Yep. V 2, 4, 6. Yep, that'll work. So I'm going to translate it 6 units to the left. So that's going to be -6, 0. All right, so we were able to map one triangle onto the other. Now these look like parallelograms to me. So let's do the same for them. Let's let ABCD be the original. And ABCD. So let's do ABCD. So let's do HIJK. So HIJK. All right. So let's see what we need to do. I think we just have to translate it. If we take C, start with 1 point, and we move it, we want it to be right above J. So that's 2, 4, 6. 6 units to the right, and then 2, 4, 5 units down. And if we do that to every point, 2, 4, 6, and then 2, 4, 5, it's going to translate perfectly. All right, so we are going to translate 6 units to the right and 5 units down. And we will have mapped one figure onto the other. So this is really just putting together what you did all last week. All right, let's go to part 3. This is going to be on your next page. This is page 580. Identifying congruence transformations. Because compositions of rigid motions map figures to congruent figures, they are also called congruence transformations. All right, so we talked about identifying congruent figures, and we talked about doing congruence transformations. Congruence transformations are just a composition of rigid motions. It's mapping one figure onto the other. All right, show the mapping and verify using the original coordinates. In the diagram at the right, triangle JQV is congruent to triangle EWT. What is a congruence transformation that would map JQV onto EWT? So let's start with the J and the E. If I'm going to map J to E, okay, think about what you're going to do, okay? You're going to go up 2, 4, 5. I'm going to go up 5, and I'm going to go to the left 4. Or, to make sure you put it in the right order, you could say you're going to go left 2, 4. I'm going to go up 2, 4, 5. So that would be left 4 and up 5. That would make sense. Now, if we're going to do each one at a time, let's see what we would do. I want to take and I want to translate J first. All right, so as I was looking at this one, even though I can translate J to E, if I wanted to do Q and W, it's not going to be the same. So you can't just do one transformation. You're going to have to do more than one. All right, so let's see what we can do. Let's translate just J for a minute. And let's just move it 2, 4, 5. Let's move it 5 up. Just go up 2, 4, 5, just to make it right across from E. Okay. All right. So we're going to translate 5 units up. We're going to translate point J. Okay. So 2, 4, 5. Okay. Now this is J prime. Okay. That is now 2, 4. That's our new point. All right. Now let's do the same for Q. Let's translate Q, point Q, 5 units up. So that's 2, 4, 5. So here's Q prime. And that ends up being what? 1, 1. All right, let's translate V, 5 units up. All right, so that's 2, 4, 5. So this is V prime. This is what we have at first. All right, now if you look at it, this is going to be an easy reflection. Q prime onto W, J prime onto E, and V prime onto T. So that's going to be your reflection over the y-axis. Okay, I know I just erased all that, but you see it. So let's go write that now. The second thing we did is, and I'll do this in red, we're going to reflect over the y-axis. When we reflect J, which was right here, over the y-axis, we get -2, 4. All right, when we reflect over the y-axis, point Q, we're going to get -1, 1. -1, 1. Okay, and I never did put this one, did I? For V, it was 5, 2. And we reflect it, it's going to end up being -5, 2. So we're going to reflect over the y-axis, point V, and it's going to be -5, 2. All right, so what did we do? We took triangle JQV and we translated it 5 units up, and we reflected it over the y-axis to create triangle EWT. All right, let's look at this next one. This next one is going to be got it problem number 3. And if you want to just watch this one, you don't have to do this one for, oh yeah, you do have to do this one. Yeah, we are doing this one. Sorry. Yeah, this is the got it problem. You want to do this one. This is got it number 3. It's number 4 that you don't have to do. All right, got it problem number 3, found on page 580. What is a congruence transformation that maps triangle NAV to triangle BCY? All right, so let's see. Let's translate triangle NAV. Let's take it and let's just move it down. Let's take V and let's move it down. 1, 2, 3, 4, 5. That way it will be even with B. Okay. All right, so that's going to be V prime. Take N and move it down 5. That's N prime. And take A and move it down 5. That's A prime. All right, so we're going to take triangle NAV, and they want us to map it onto triangle BCY. All right, so the first thing we did is we translated it 5 units down. All right, the next thing we want to do, let's go ahead and draw this out so you can see it. Is we're going to that's not going to work. So let me erase. I want to do 5 units to the left, not 5 units down. So 2, 4, 5. This will work. B prime. 2, 4. Let's see. 2, 4, 5. That'll be N prime. And then 2, 4, 5. That'll be A prime. Yeah, this is going to work because it wasn't going to reflect the other way. And I had written it like I was going left anyway, so I don't know what I was thinking. Because if I was really going to go down, I would have written the translation like this: 0, -5. I went down and tried it, but that didn't work. All right, so this is going to work. So now I can reflect it over the x-axis, and that'll work. So we're going to say we're going to reflect it over the x-axis, and that's what we'll get. And we could do each point if you want to, like we did above, but I think you get the point. All right, let's go to part 4. Part 4 is on page 581, and it is a proof. So we're just going to skip that one. You can read it in your book. It gives you the steps, and you don't have to do that got it problem. So let's move on to problem number 5 on page 582. Is figure A congruent to figure B? And explain how you know. Well, you're looking at it, you're like, yes, of course it is. So figure A can be mapped onto figure B with a sequence of reflections or a simple translation. So I could take figure A and I could translate it to the right and move it up, or I could take it and I would translate it up a little bit and then maybe reflect it, or I could translate it up a little bit and I could, let's see, let's put a line right here, and then I could rotate it. All right, so yes, figure A can be mapped onto figure B. So we're going to say figure A can be mapped onto figure B by a sequence of translations or transformations. So figure A is congruent to figure B because of congruence transformations. All right, the last question we're doing is going to be this one, and this is got it number 5. So this is the other one you'll be doing. Are the figures shown at the right congruent? And of course, you automatically know it's no. But what's the reasoning? They have different side lengths. All right, so let's see what your homework is. You're going to upload got it question numbers 1, 2, 3, and 5. And then your practice problems are going to be 1, 2, 7, and 9. All right. Have a good day. Talk to you later. Bye.